So let's talk briefly about the different states of matter. We've talked about these before. Here we're looking at water, the gas state or phase we call steam. Liquid water we just call water, and the solid form of water is called ice. And here are illustrations of the particles, the molecules, what they're doing, and also the densities. So we see the density of liquid water and solid water, ice, are very similar, 0.9, really close. And the density of steam is extremely low. It's 0.00059, much less. If we look at these illustrations, the molecular view, in the liquid and the solid, the molecules are touchingly close. They could reach out and touch someone, right? Here, they're all fixed in position. They're not moving relative to each other, but they're wiggling back and forth. Just like you guys are all sitting in your chairs, but everybody's still breathing. So today's been a successful lecture. Here is like when we're practicing our lab practical in lab this afternoon, we're still going to be confined to the same space, but everybody will be moving around. And here, there's a lot of distance between the particles. The major difference between solids and liquids is freedom of movement. So in order for a solid to melt, to become a liquid, the kinetic energy has to overcome the intermolecular forces that are holding those atoms in place. It doesn't have to completely overcome them to go into the gas state, but it needs to partially overcome them so they can slide around. And so these are characteristics of states of matter that you should understand. Okay. Density, gas has low density. In terms of shape, gases and liquids are both indefinite in their shape. If you put a liquid in a different shaped container, the shape of the liquid changes. But if you take an ice cube and you put it in different containers, it stays the same shape. So it has a definite shape. Gas has an indefinite volume. It will expand to occupy whatever container it's in, whereas liquids and solids retain the same volume no matter what they're in. Liquids assume the shapes of their containers because the molecules are free to move relative to each other. And so they're going to move to the bottom because gravity is going to be pulling them to the bottom. Gases are compressible. They have an indefinite volume because there's so much empty space. So here we have one of those piston assembly things that we saw when we were talking about gas laws. And if you push hard on this, you can squeeze the gas closer together because there's a bunch of empty space. Here's a liquid. You can push on that really hard and you really can't compress it at all because the molecules are already touchingly close. And that's good because otherwise hydraulic brakes would not work. When talking about solids, we can divide them into crystalline solids and amorphous solids. A crystalline solid has a regular repeating structure. So we see that there's lines of atoms here, and it repeats in 3 dimensions. Amorphous literally means without shape. And so there's no pattern, there's no organization here. The molecules or atoms are just all jumbled together, they're just thrown together. So this is an extremely fair exam question. Which state of matter is compressible? A gas. Changes between states. We know that ice melts into water, and you can boil water or let it evaporate and it will become a gas. These state changes happen due to changes in temperature. So if we take a solid and we add heat, we can get a liquid. If we take this liquid and then add heat, or we can reduce the pressure, we'll talk about that later, we can make it into a gas. And then to go the other way, we do the opposite. Increase the pressure or cool the gas to form a liquid, cool the liquid to form a solid. Here's an illustration of a propane tank that you might have for your gas grill in the backyard. So this is LP gas, which is liquefied petroleum gas. It's mostly propane. And so here in the liquid form, the gas occupies a much smaller volume. So this tank here will contain enough gas to grill a whole bunch of hamburgers, right? Whereas if you were buying it in the gas state, you'd need this huge container to get enough gas to do that. So this is the liquid, and the liquid does evaporate into the gas state, so there's going to be some gas up here. When the valve is opened, gases, they travel in straight lines until they run into things, and then they bounce off and they keep going, and they are going to make their way out of the valve. As these molecules in the gas state leave, more of the liquid will evaporate, and it'll just keep going until it's empty. So here we have a diagram showing a sample of liquid water, and these are the little, red is the oxygen, white is the hydrogens. They look like little Mickey Mouse heads to me. And we're asked which of the diagrams best depicts the vapor emitted from a pot of boiling water. I've heard a couple of votes for A, and that's correct. Because when you change the state of water from a liquid to a gas, you don't change the particles. They are still water molecules, right? So we still have the same water molecules here. The only thing that's different is they are farther apart from each other. To make them back into a liquid, we can cool them down or push them together, and they'll be like this again. This one shows us destroying the water, breaking it into oxygen and hydrogen gases. That doesn't happen when you evaporate water, thank goodness. And this is hydrogen and oxygen atoms, which just kind of really doesn't happen. Any questions?